Hey everyone, welcome back. In this video, I'd like to introduce the new preamplifier that we're going to be producing starting in the new year. So Don Sachs and Lynn Olson are the technical gurus behind this as far as the electrical circuit design. And Don has always wanted to work with me, and he approached me and wanted to see if I would be interested in producing a line of preamplifiers and amplifiers. He obviously knows my design ability as far as speaker design, but he was convinced that I would be able to build and design and build a chassis that complements what they're trying to do as far as the sound quality. And so the 2P29L vacuum tube is a beautiful sounding vacuum tube, and the system that we exhibited at the recent Toronto Audio Fest used the finished circuit design that will be used in the finished product. And so we just recently won the Blue Note Award from enjoythemusic.com for Best at Show. And so part of the reason why that room sounded so good, it wasn't just the speakers, but also the preamplifier and monoblock amplifiers that were upstream. And so in this video, what I wanted to do was bring you guys along on a kind of a design development journey, because the design of the chassis is not fully finalized. In keeping with, my other videos and content, I do technical deep dives and I bring everyone along and explain everything as far as the technical side. And whether or not you're actually a potential customer or not, to me, it's irrelevant. It's really an academic interest to bring you guys along, and hopefully there might be a bit of a collaboration where you can see what I'm trying to do, because I'm also learning. This will be our first attempt to design and produce and manufacture electronics. And so by having you guys come alongside, there might be a benefit in that you'll understand fully what the product is when we're done. You'll also be able to potentially offer advice to me as far as, design features and suggestions on ways to improve the design. I fully recognize there's a risk in doing this because obviously you're exposing your IP and you're at risk of other people attempting to copy. But I think the pros outweigh the cons here, in that everybody can see the level of detail and focus that we're putting on this product. And I'm not to say that other products don't have that level of detail, but I don't think it's very common that a manufacturer like myself will be this candid and open about not just the design, but also the design process, and walking you through. And I'm bringing you alongside on this journey. This is, like I mentioned, the first time producing electronics, but I feel like, as far as design, I have the chops to do it. We have the technical expertise as far as assembly and testing. I'm familiar with the inner workings of tube amplification, but not to the extent of Don and Lynn. And so with Don Sachs and Lynn Olson, I'm leaning pretty heavily on them for a lot of the real electrical theory side. And so it's actually maybe a good thing that I've relegated that to just their kind of wheelhouse, and then I'm able to exercise what I feel, where my special capabilities are, which is on the mechanical design side. And so what I wanted to do in this video, kind of a late way of intro to the video, but is actually just go through the design in SolidWorks and show you the 3D CAD model and where we're at right now with the chassis design, and show the features that I have come up with where I think it's going to provide truly exceptional electrical, acoustical, and mechanical vibration isolation from the various components. And Don has guided me through, and Lynn has provided feedback thus far, where I've sent them kind of design review videos as like unlisted videos on YouTube, and then they'll watch it and then provide feedback on, okay, move this transformer, make it closer to the, the output, input output on the back and little things like that, and trying to figure out wire paths. And I understand that these are a very common kind of design processes when it comes to design development, but I think it would be really cool to just have you guys come along and see the literal nuts and bolts of what we're trying to do. And so you can see here, I'll just show my actual hand scribbles of trying to come up with a design layout. And often is a case you literally have a case, box, power supply, and then you have the signal side, and you have it divided by kind of like a steel plate to provide shielding of the power supply against the rest of the signal circuit. But the tubes that we're using, the 2P29L tubes, are particularly sensitive to vibration, microphonics. And so we needed to, in order to use these wonderfully sounding tubes, we needed to isolate them adequately from the rest of the chassis. And so you can see in the 3D CAD model, the way that I have it is there's a large steel base plate that houses the power supply. And then coming right up through the feet are these columns which hold the upper level. I would call it the second level. And we're building it almost like a building, where you have the first floor as a power supply, and then this second level is also made out of steel to provide the proper shielding to the level above, provide shielding on the second level against the noise of the power supply below. And so not only does it provide the electrical shielding, but the upper level is completely floating on rubber isolation. And so I've just kind of put in, stand-in parts, what I think would provide adequate mechanical isolation, but it's not going to be finalized until we physically have the chassis built with the components to kind of assess the weight of the subassembly that's floating above the power supply. And then McMaster Carr actually has various durometers of that spring feature that you see there. It's almost like a leaf spring. And so by choosing the proper durometer, we can kind of perfectly suspend that upper assembly to provide complete mechanical isolation from anything below. And so not only did we provide isolation for the second level, which houses the Cosmo stepped attenuator, but we're doing the exact same thing. We're continuing the columns all the way up through to the very top. I call it the third floor. And this is where the tubes are mounted. And so this plate is actually going to be made out of copper, which has excellent mechanical EMI and RFI shielding. And so that, again, is mechanically isolated with the same style of rubber leaf springs, if you will, to completely isolate the tubes mechanically, acoustically, and damp them from any kind of vibration. Just going back a little bit, the amplifier is fully balanced. To accommodate fully balanced, you really need very, very low noise regulated supply to the tubes. And so to achieve that, we're using a Canadian company called Neruochrome. And it's a small company, but Tom Christensen is the owner, designer, and he's introduced these regulated filament supplies that are MOSFET based, that are extremely low noise. And so they're housed along with the power supply, and it requires pretty significant thermal dissipation, which explains kind of the stepped design where we're allowing the chimney effect through the power supply level and dissipating the heat of those neruochrome MIDA supplies. So the other feature is the large solid hardwood front face. And so being a direct sales manufacturer and doing the design myself, also doing the CNC work myself, I'm in a unique position to actually offer the customer custom options for the actual wood front, whether it be and being able to, the customer can select custom wood options to suit their rack. And so they can have cherry, birch, walnut, and then different design motifs to suit their own kind of preference on that. The volume knob there is my own kind of idea to have a high mass design where when you rotate the volume knob, it's similar to the vintage receivers with the tuner, where you have a high mass momentum to the turning of the knob, and it allows the knob to continue to rotate if you can give it a good kind of the wheel of fortune spin. The electrical volume knob actually allows push detent to toggle through the inputs on the Cosmo attenuator. And so the shaft will be sized so that it's a slide fit, allowing you to continue to still be able to push the volume and allow that selection. And so the electrical knob itself is fairly lightweight, only intended for a lightweight, small aluminum volume knob. And so it will be housed inside the preamplifier and attached to the shaft with a shaft coupling. Also, we've introduced our new simplified logo, which will go on the front face of the products, including the front face of the speakers as well, to help visually identify the brand. And this isn't to replace the circular logo, but just a more simple option to create a clean visual of the product without having our regular circle decal. So that'll be interesting. And then we're looking also at being able to backlight the logo on the electronics so that it has kind of a soft amber glow to match the LCD screen from the Cosmo attenuator. So that's a good ending point for this video, part 1. Stay tuned for part 2. Also, if you could, please let me know what you think of this as a video series in terms of walking you through the design. Is it kind of boring? Is it it's okay? Or is it just really cool? If it's really cool or either way, let me know. I'd really like to get your feedback. If you have actual suggestions on the design or questions, certainly leave a comment in the video. So that's it. Take care. Have a wonderful day.